So two kind of quick things. One, let me just pick a random project here because this did cause sort of an issue for a few people. When you share it, remember you don't just copy this link, right? Because if you copy that link, all it's going to do is take you back to the editor. You've got to hit the share and publish button, and then you'll get the actual link. That a few people messed that up last time. Okay, and then the other thing was hopefully we will not have the same problem where Canvas didn't assign peer reviews automatically like it was supposed to. So I'll make sure that it doesn't screw that up this time. So, but I think everybody got theirs done. So for the first round. So yeah, good. Okay. So that was kind of it for the May code, or sorry, the just business announcements. What I kind of wanted to do is let's actually just go back to a project that we've looked at before, and this was let's see here. This was the monkey, right, thing, okay, and where we had nothing special. And this is before we'd put in any animations or anything like that, but just real simple, simple stuff. Okay, so what I kind of wanted to do for the last couple of, I mean, this is the last week of class, right? In advance for, the really soul-crushing final exam that you'll be taking next week. Gotcha. Yeah. Is kind of do sort of two things. One, to think about, okay, how do you take what we've learned here and sort of transition to other languages, okay? Be them textual languages like Python, okay? Which for those of you who take CS111 next semester, which I think a few of you said you're signed up for, um, obviously that's what you'll be doing there. And Python or C or any of these sort of other languages are text-based, right? There's no graphical putting blocks together. It all looks like this, okay? And so I kind of wanted to sort of talk about the transition, if you will, for how we can sort of think about what we've learned in this graphical code structure to more textual code structure like Python. Okay. The second thing I wanted to do is sort of talk about that graphical coding is. I maybe lied a little bit at the beginning of the course, in the sense that graphical coding, like with MakeCode or Scratch, or there's a bunch of other languages, right? These are things that have been developed over, say, the last 20 years or so, and what they have done is given a very easy way to teach programming to people who've never programmed before or kids. Okay, um, and but I think you guys have sort of noticed as you're doing your games that at some point you kind of hit a wall where having the blocks actually is getting in the way of your programming and not helping you. And maybe you guys would disagree with me on that, but eventually it kind of gets cumbersome. Okay. So, but part of that is not the idea that it's blocks. Part of it is just how things are organized and what tools we have available to us. Okay. So the other thing I wanted to show you guys is a block-based language uh, that is AAA game title. You could program Fortnite in block-based code. Okay, so we'll look at Unreal Engine's blueprint system, which is visual coding, but kind of taken to 11, if you will. And I don't know, how many of you guys get that joke? Right? Take it to 11. What's that movie from? Mm-hmm. Spinal Tap. Yeah. He's got, the amplifier for his electric guitar, and he's like, this one, right? This one's special. It goes up to 11. Why don't you just make 10 louder? Oh, that's just not the same. Right. So, yeah. Anyway. Oh, look, it's somebody else I get to ban from the stream because they're a spammer. So let's see. Let's ban them. Um, all right. So yeah. Anyway, the point is that visual coding is still actually useful, and so some of the limitations. Thank you so much. Yeah, I was gonna say that. Huh? The new car. the the credit limit on this is not good enough to buy you a new car. So, mhm. No, he was here early actually, and I had to. So we've got a couple of math job candidates here right now, so I had to go pick them up at the hotel and then chauffeur them to campus and so on. And so I didn't have time for my morning run. And Colin was here early, and I was like, "Make yourself useful." Hmm. Yeah, it was an exchange of goods and services. Yeah. So, um, okay. So yeah, to look at sort of a real scripting system, or visual one, and we'll use Unreal Engine simply, well, for a couple of reasons. One, that's the one I'm familiar with, but two, like I said, it's extremely powerful. Okay, so the what I wanted to kind of talk about, at least for right now, is uh, what this equivalent thing looks like in Python. Okay, and so one of the things I really like about MakeCode is that you can switch back and forth between block-based and Python or JavaScript, um, kind of freely, and it will translate stuff you do on one part to stuff that you do on the other. So if you switch it over to Python, add some code, assuming that it's valid, and then go back to the blocks, you'll see the equivalent blocks appear. Okay, which is nice. So what this kind of gives us is, for lack of a better way of putting it, almost like a little Rosetta Stone. Okay, so what is the Rosetta Stone? Has anybody actually seen it in person? No? The Rosetta Stone? Yeah, what is it? Right. So the same thing is written on it in multiple languages, and this was sort of the key to cracking some Egyptian language, because we had the Egyptian, we had several other things, so we knew it was saying the same thing in multiple languages, but we also had the Greek, and well, if you happen to know Greek, then yeah, right, Eli? Sign up for Greek. Okay. I was giving him the Take Greek speech on Saturday. So, yeah. Okay. So, anyway, um, the if we go back to the blocks, let's just kind of look at a few of the things that we have, just to kind of orient ourselves. So we've got the on start event, and then we've got, in this case, several of these on overlap events. Okay. And in that case, the overlaps are, there's multiple of them because we've got different types of overlaps. We could overlap with this sort of orange thingamajig, the treasure chest, the poisonous flowers, okay, whatever. In this case, that's what they are. And each one does something different. Um, there's not a whole lot of code there. And then we've also got an on and up button pressed. Okay, so not a whole lot of blocks of code for this particular program, but we can kind of look at the Python part. Okay, so um, what we have here are a number of statements like that look like this up at the top. Okay, so anytime the anytime that you're defining a block like an on overlap or a something like that, okay, that's basically code for we're defining a function, okay? And Python defines function. They all come after the word def, right? Because we're defining something. Okay, and so then what follows this is the name of the function, okay, and parentheses, any parameters that it might take, okay, so in this case it's called sprite2 and location2, and then a colon, that's just the way it is, and then what happens if this function runs? It does whatever is inside of it. Okay, so the inside, what's inside a block is really obvious in the block-based view, right? You just look at it. Okay, how do you tell what's sort of nested inside something in Python? It's handled purely with tabbing. Okay, so you see how there's a tab of space before the game over true? That's how I know it's part of the thing up above it. Okay, so everything is purely done by tabbing, and you just learn to read this. So let me actually add in something here just for giggles. Okay, so let me add in an if true. And let me just put a couple of random things inside. Okay, so I'm just making up a few things here. Okay, so if I've got an if statement, so let's go back to the Python, okay, and find where that is. It's here, okay? So if true, then what happens? It plays one sound, and if it's the condition's false, it plays the other. Okay, so you see how the thing that happens in the true or the false case is tabbed over one level from the thing up above it. Okay, that's how you know what's inside what, so to speak. And obviously, you could tab over as much as you want if you had nested structures. Okay. So now this is in contrast. So let me put this over in JavaScript mode, for example. Um, you see how there's these curly braces? Okay. In JavaScript, Java, C, C++, a number of languages, you tell what's inside of what based on the curly braces. Okay. So if true, curly brace, the stuff that's inside that pair of curly braces is what happens in the true case. And then I've got an else and another set of curly braces that tells me what happens in the false case. Okay, now you'll notice that everything is still tabbed over. Okay, why? It doesn't have to be, but it still is. Okay, so why would you still tab it over if it's not required in this language? It is in Python, but it's not in JavaScript because we've got the curly braces to tell us. So why tab over? Yeah, yeah, it's easy to read. That's it. Okay, and so this sort of convention developed. Well, the spacing doesn't actually matter, so I'll just tab things over to make it easier to read. But the curly braces are what really matters. And then everybody's like, you know, this tabbing over thing is actually pretty easy. Why do we need the curly braces at all? Yeah. And so Python, one of the nice things about it is it just says, forget it. Let's just dispense with the curly braces and not have to worry about that and do it purely based on the tabbing. Now, Python is a newer language to some extent. It first started being developed in the early 1990s, and I don't think I learned about its existence until probably late 90s, early 2000s, somewhere in there. And I certainly didn't use it for a while after that. But it became a very popular language later. Yeah.
space, whatever it is, and then next line right at the very beginning, you put it back together. What's up with that?
Just the convention. Now, okay, so there's two things there. One, if I put an like if I put this curly brace at the end of line 36, it would still be valid code. Okay. So, and some programmers actually, I've kind of gotten in the habit of doing it more like this. Okay, where the curly braces are on their own line, and then maybe it's easier to read that way. Um, but in terms of how this is interpreted by what's called a compiler, it just ignores the spaces. So it doesn't actually matter um, to which way I do it. Now, in this case, so we created this code in blocks, and then I hit the button, and the program translated that into an equivalent Java script or Python, right? But this was machine produced code in the sense that I didn't type all this stuff out. Okay, so in you know, however that code translation thing is doing, it put the curly braces in the way that we saw them a minute ago. That is syntactically valid, just as what I changed it to is syntactically valid. Yeah.
Like go one to the end, jump to go two, like if you're doing both, but you just need one that's
Yeah. And you'll notice, I mean, this may be a little hard to see on the screen, but it's an open curly brace followed by a closed curly brace, right? And so, as you could imagine, then if you have a really big program, what invariably is going to happen if you're doing it in a curly brace language? You're going to get off, okay? And you're going to be missing a curly brace someplace, so you'll have an extra curly brace somewhere else. And this is why you don't program at 2 in the morning, because you know what you cannot find at 2 in the morning? That dang curly brace, okay? You will not find it, no matter how hard you look. Whereas if you just go to bed and you wake up the next day, in 2 nanoseconds, you found it, okay? Um, yeah, so this is one of the reasons I think that like teaching Java or C as the very, very first language that somebody encounters is not really a good idea in many respects because they're very they're very picky about the syntax. And if you mess up some of the syntax, that is going to happen a lot, and it's very frustrating for a new learner of code or of programming. Okay, so this is why I think the block-based languages, where the block-based languages, it's almost impossible to make a syntax error, right? Like it either is inside it or it isn't, right? It's very obvious which one of the cases is. Um, and that allows the learner, you guys, right, to learn to concentrate on the logic and the flow without having to be so caught up in the syntax. I mean, this would be kind of like, um, I mean, for just to make an analogy here. Okay, so you all took languages in high school, and some of you are currently in language classes here. What languages did you guys do in high school? Yeah, well, we've had this conversation. Right. Supposedly you took French. Okay, Spanish, who had Spanish? Yeah, most of you. Okay. Other languages? Well, you took English, right? Uh, yeah, what else have you studied? Did you? Okay. Well, we may need you, comrade. Uh, depending on what Putin decides to do tomorrow. Um, yeah, okay. So imagine if you walked into your first day of Spanish class, okay, and so what was your first day of Spanish? Well, okay, let me back up. Who's taking a language here? Okay, which class?
Spanish 201.
201. Okay, anybody else? Yeah, same thing? Okay, so you walk into Spanish 201, and what happened? Professor Rogers or Hardy walks in and
he greeted us in Spanish.
Yeah, right. Immediately, day one. You know, hola. Well, what's the plural?
It's como está.
Están instead of estás. Right. Okay. Right. ¿Cómo están? And you were expected to be, oh, well, muy bien, merci. Or see, this is what happens. Every time I try and say something in French, or sorry, in Spanish, French slips out. Right. It's very frustrating. Okay. So anyway, point being, right, you got to your language class and you were speaking it. Okay, and engaging with the culture, the food, the different countries and whatnot, right? Okay, so let's pretend instead that you walked into Spanish and I handed you a giant tome, you know, stuffy old dead white dudes, complete Spanish grammar, and said, page one, let us examine the conjugation of participles in the language, right? What would you guys think? Yeah, you'd be like dropping that class faster than, I don't know, faster than something, right? But you'd be out of there, okay? Um, and to some extent, then, right, the trying to train a very beginner on a language like C or Java is kind of like that because they have to worry about the grammar in addition to all the stuff that, the actual logic and flow. And cognitively, it can be a little bit too much. Okay. Which is, like I said, why I like the block based stuff as a very beginning language, right? It allows you to lessen your cognitive load and concentrate your cognitive load on the program flow and not having to worry about the syntax and stuff because that can come later. Okay. Um, so yeah, I mean, I think of this as like even high school Spanish, right? So you don't know a word of Spanish besides taco, and you walk into your Spanish class the very first day, and what happened? The teacher comes in, and what do they say? They greet you in Spanish, right? Why do they do that? Right? So the very first day of French 101, I walk in, I'm sitting down. Professor Stokes, uh, rest his soul, walks in and, you know, bonjour à tous, comment ça va ce matin? Right, and just goes on and on, Je m'appelle Professor Stokes, je suis un professeur de français, and so on and so on. And of course, how many of us had any idea what he was saying? Essentially nothing, right? We were getting almost nothing out of this. But what was the point of that?
So you can start hearing something in French, and
Right.
famous greeting.
And immersing yourself in it. Okay. But did he start with French verb conjugations on the board? No, Lord, no. I mean, that's important, but it's not what you're going to do day one. Okay. Um, yeah. Okay. So let me go back to Python here for just a second. Okay, instead of JavaScript. And the reason I'm more going to concentrate on Python is because those of you who take CS111 next semester, and just quick show of hands, who signed up for it? I think one, two, three. Um, not you two? Yeah, why don't you sign up for 111 next semester?
Didn't have time on my schedule.
Oh, well, make time. Make time for Greek too.
I love my senior year.
Okay.
But that's what I decided.
Well, some people like to live dangerously. Uh, See, the downside to that, other than leaving it to your senior year, what happens when you get into it and you're like, this is the most awesome thing ever. I want to take more Greek. Too late. Yeah. Don't let that happen to you because Greek is so awesome, you'll want to take more of it. Mm, I don't know. There's a pretty good book written in Greek. So just saying. Huh? Okay. So anyway, so let's look at let's take, for example, the on up button pressed. Okay, so what happened in this game when we did the up button in the monkey game? It had that gravity jump function. Okay, and that was nice that it had that built in because it didn't permit double jumping. And I think we talked about that. Okay, so the way that this is going to work is it's kind of interesting how it did it. The first thing is what happens if we hit the up button? Well, what did we want to have happen? The sprite gravity jumps, right? Well, which sprite gravity jumps? My sprite, which was the name that we gave to the monkey. Okay, that's just whatever. So this is the my sprite part here is saying, well, which sprite do we want to have gravity jump? What's its name? Okay, my sprite. Okay, whatever. Now, the rest of this bit here, sprite dot gravity jump of my sprite is how I read that. Okay, and Python here, what this has done is it's sort of an object-oriented thing, and so there's a category of things called sprites. Okay, my sprite is a member of this category, and sprites can have functions that go with them. Amongst other things, there's the one for gravity jumping. Okay, so gravity jump is a function that's defined for the category of objects called sprites. Okay, and the dot says that it's within the category of sprites. So, for example, let's say that I had sprites dot gravity jump, but I also had I don't know, like background dot gravity jump. Those two gravity jump functions could be different. And maybe, you need a different kind of gravity jump function for one category of things versus another. Probably not. I'm just making that up. Um, but yeah, okay. So then the next line is this is more specific to the fact that it's a game thing, right? What we're going to do is actually define or rather bind this function to the pressing of a button. Okay, so the controller is another category of things, and it has functions, okay, for on event when something involving the controller happens. And in this case, the event is if the up button is pressed, I want to trigger the function called on up pressed. Okay, so if I hit the button, the event controller button pressed for the up button has been triggered, and then this says when that happens, trigger the function on up pressed, which is this function right here. So it would run that thing. Okay, so I know that looks a little weird, but that's how they designed MakeCode anyway. Um, yeah. And now the benefit of that, right, is that you see where it says dot pressed and it's all in all capitals there. There were other options that you could put there, like you could have an event trigger if you released a pressed button. So if you were holding the button and then you let it go, then something would happen. Or an event that happens whether or not you press or release. Okay, just depending. Okay, but in our case, we wanted only for the jumping to happen to get triggered when you press it. Okay. Um, okay, so that kind of makes sense. The sort of the structure of this, um, and then well, a couple things that you guys noticed as your program or your game gets pretty complex, you've got lots and lots of blocks, and it can be visually kind of difficult to keep them organized. Yeah. So how else could you organize things if it's text like this? Because if you had a really, really complicated program, it would just be like pages upon pages of text here. How could you keep that organized better? Any ideas? Yeah. Yeah, exactly. So I could move a lot of these things around. In particular, all of these def statements can be kind of in any order I want. Okay. not extremely, not perfectly any order, but essentially, okay? The other thing that I could do, and I can't do this in make code, but if I were doing this on, in quote, real Python, I could, is there any rule that these all have to be in the exact same text file? No, of course not. So you could have separate files that are all linked together in sort of a main file and have one of the files be music and the other file handle controller stuff and another file have all the stuff for whatever. And then you would have to link them together and sort of say, hey, this load in the stuff from that file and this other file. Okay, now you can't do this in make code because that's just the way they set it up. But you could do this in a quote real development environment. Yeah.
So I know from like an accounting business perspective, you can do the exact same thing with Excel.
Mm-hmm.
That's a huge no-no because if you don't have the link file, your program or your Excel file won't run. So how do you keep those linked together, or do they kind of like download across?
You'd have to provide all of them, right? Okay, and then with Python, this is maybe not as good of an example, but um, with like, let's take like a video game, that you make. What you provide the customer is not the source code, right? So the source code is stuff that you have, and you compile it and do some other stuff to sort of bake it, if you will, into a form that you then give the customer. And the customer gets sort of a self-contained thing that has everything that's needed to run, along with all the art and so on. Okay, so yeah, but let's say, for example, that like you're in CS111 and you've got a program that you've written and it has 3 subfiles and you forget to include one of them, it just won't work because I'm trying to use something that's not there. And so I'll get an error and then I'd have to say, hey, dude, bro, where's the missing file? And you'd say, oh, I'm sorry. And right. You'd just be SOL. Okay. Um, and right, which of course, now the downside to having lots of different files is if you're not smart about how you organize it, then finding the piece that you need or choosing where you add more code, like you can turn this into like a spaghetti rat's nest of things that are referring to things that are in other places, and it's impossible to kind of mentally keep track of all of it. Um, yeah, you will make those mistakes, right? And in some sense, that's part of the art of learning software development is learning what are good practices and what are bad practices. And sometimes the best way to learn is by screwing it up and saying, never again. Okay. Um, and well, or you like, there are some lessons that you have to learn by screwing it up yourself. I could stand up here and yell at you until I'm blue in the face about do or don't do something, but is that really going to sink in until you kind of try it and fail, right? Keep this in mind, by the way, if you guys ever have children, right? Sometimes it's best to just let the child go over do this thing and fail because that teaches them a much more powerful lesson than if you told them not to do something, right? So, like, how many of you guys ever stuck your finger in an electrical socket when you were a kid? Yeah, of course. And did anybody ever tell you before then, don't do that? Uh-huh. And did you listen? Well, clearly not. Okay. Did you ever stick your finger in an electrical socket a second time? He probably did. Okay. Uh, because this is Colin we're talking about, right?
I also like changed our DVR to French and then like we kind of get it back.
So this is hilarious because this means that you had a DVR when you were a kid. You know what our DVR was? Well, it was really an AVR. It was analog, not digital. But there was a way you could wire up a camcorder to the TV to record stuff that was being broadcast. But the TV had to be tuned to it, and you had to tape it, and then you could watch it later. These were dark times.
Well, those are the best.
Hmm? Both, right? I mean, like if I wanted to record some movie and then I watch it and then I don't want it again, I'd reuse the cassette. Or, right, I'd have to have lots of cassettes for different.
Because that was like real like pirating again.
Mm-hmm.
Like then because it's like
You really had to do something.
yeah. Those were the days. You know, like a 50-pound TV the size of a shoebox. Oh, 50 sound. Yeah, and
Yeah.
VCR the TV.
Yeah. I was going to say a 50-pound TV the size of a shoebox, right, is like you want a real TV, right?
You know, like the one that like the antennas on top,
Mm-hmm.
like the VCR like over it.
Yeah.
Yeah.
Yeah. Not right this instant. I'm trying to teach class, Kobe. Thanks. Um, yeah. So, um, where was I? I'm sorry. Why? How do we get onto the subject of old televisions? Oh, yeah. Right. So Colin, how many times did you stick your finger in an electrical outlet before it finally dawned on you that maybe this was not a good idea? Was it just once? Oh, okay.
We'll say we'll say yes.
Yes. Okay. So, well, I only stuck my finger in an electrical outlet once. Okay. In fact, I can tell you exactly which electrical outlet it was and in which house, right? In which room. And actually, amusingly enough, maybe about 5 or 6 years ago, so it was at my grandparents' house, and that was the room that I was going to stay in when I was there visiting for Christmas. And so I'm plugging my phone in to that outlet, and it like shorts out on me. And I'm like, oh, not this outlet. That's the evil outlet. My dad's like, what are you talking about? I'm like, Dad, we need to change an outlet. He's like, why? And so while we're changing it, right? So my dad thinks he's like an electrical pro because his dad was an electrician. Um, he's so if you're changing out an outlet, what's the proper procedure for this? You turn off the breaker. Did my father do that? No. And now he was wearing gloves while he was doing this work, but like it shorted and blew the breaker because actually there was something wrong with this outlet. Like I'm surprised it didn't burn the house down years ago. Um, yeah, anyway. And so it sort of shorts and shocks, and he's like, what the heck? And I'm like, this is the same outlet that told me not to play with electricity. So what are you talking about? I'm like, well, when I was like 2.5, I stuck my finger into this outlet, and I learned a very good lesson from this outlet. And now it's time for this outlet to go. So, yeah. Um, but okay, so the reason I bring that up is like you have to learn some of the lessons of software development from experience, right? Which means messing something up or thinking that this is a good way. And then 12 steps down the line, you realize, actually, you know what? I should have gone back and redone it from this other perspective. And some of that, like I said, you just have to learn from experience. There's no like hard and fast rule as to how to do everything. Okay. Um, okay. So, I think hopefully that's sort of a good way to make this sort of transition from what we've been doing to what you guys will do in future programming. It doesn't have to be in Python, and obviously a lot of the stuff that's here, like changing the score and stuff about tiles or whatever, is specific to MakeCode because it's a video game thing, right? Vanilla Python doesn't have any of that. Um, but that's enough for you to get the idea, and then all the details of how all this works in Python and how objects works and inheritance and lots of other things, right? That you'll get when you take 111. Okay. Okay. Good. All right. So the other thing I wanted to kind of start with, at least today, is let me close this. Okay, so I'm going to open this project in Unreal Engine. Okay, and it'll take a minute to load. And while it's doing that, I'll kind of uh, talk briefly about a little bit of the history of Unreal Engine. So, how many of you guys have played Fortnite at some point? Okay, yeah. What about any other game that you know that's used the Unreal Engine? Oh, okay. What games?
Destiny 2.
Okay, can't remember.
Pretty sure Elden Ring.
Yeah, I think Elden Ring does. Yeah. Okay, good. Um, any others? How is Elden Ring, by the way?
I've played very little of it. I, yeah, I think it's a good game. I just don't think it's probably something that I don't probably for me. Like I just don't think I just not huge into kind of just exploring for hours on hours
Okay,
just by myself.
okay. What do you have it on a console or
Yeah.
okay, okay. Is this loading? Hopefully it's loading. Let me double check. Um, I think it is. I thought I launched it.
There we go.
Yeah, okay, that's right. We had this bug with it where you had to launch it and then open it, not the other way. Okay, so anyway, so you all have played games with the Unreal Engine, right? And those games were all Unreal Engine 4 dot something. Okay, nothing commercial has yet shipped um, with Unreal Engine 5. Um, but back in the day, when the very first version of the Unreal Engine came out, it was Unreal Engine version 1, okay, for a game called Unreal. I know, real creative, huh? And this game was pretty dang cool for back in the day. And if I pulled up a YouTube video of it, you guys would be kind of horrified as to how horrible it looks compared to modern day games. But within there were two things about Unreal that were really cool. One was, I mean, the game was awesome. Okay, so great. But the second was that they shipped it with a level editor, right? So they shipped it with the same tool that they themselves used to build the worlds that you ran around in the game, which meant that you could build your own. And this was like amazing. Okay. For other games that had come out up until that point, Quake, Doom, those sorts of things, you could get these editors, but they were all third party people that developed them and they were buggy and not intuitive and whatnot. Um, so, um, yeah. And within this editor, most of it was about putting pieces together, kind of almost like digital Legos, for lack of a better way of putting it, to build some world. Okay. And but there was also a very, very, very primitive little scripting system in there called Kismet that they used for very simple things like if you hit this button, then that door over there closes, or this light turns on, or something like that. Okay. Um, and then as the engine developed over time, this scripting system started to get more and more robust to the point where it's now a full-on programming language, which they call Blueprint. Okay, so let me just show you, for example, this very simple game. You guys have probably played this before. And what happened? I won, and then it reset the game. Okay, so tic tac toe, nothing particularly fancy. Okay, but what I want to do is sort of look at like the code that made all this work. Okay, so for example, uh, there are 9 of these blocks. Okay, and I need to handle, well, what happens if the mouse hovers over them, or what happens if they get clicked on? Okay, and then I have to say, well, has it been clicked on already? If yes, do something. If no, do something else. Okay, and so this is block-based programming, but, well, 2 things are different. What was the order of flow in MakeCode? It was all drawn vertically. Okay, the order of flow in this one is more horizontal. Okay, whatever, you got 2 directions, so just pick one. But then these little white lines tell you program flow. Okay, and then lines that are other colors, the colors are all coded for what type of data it is. Okay, so a Boolean, what's a Boolean? Something that can only be true or false. Now that's different than, say, a number. Let me find an instance of a number. I don't think I have one here. Or here we go, block ID. Okay, so that's different from an integer. Okay, which is what is an integer? Yeah, a number that can only be uh, a whole value and including the negatives, okay, as opposed to a floating point number, which could be, things with decimals, so to speak. Okay, so all of this code here handles what to do if a block gets clicked. Okay, and as you can see, this is kind of complicated, and I don't want to really go through all of this. Okay, but I programmed the entirety of tic-tac-toe with stuff like this. Okay, and then the other thing is, I mentioned that um, it would be good to organize code in multiple different places. Okay, now you got to be careful about how you do this, but in this code for the puzzle block, that's where I put the code that deals with what happens when the block gets clicked. That's a natural place to put it. Okay, but should I put code for how to update the score on the screen here? I could, but is that a good idea? I'd say no, right? What I would want to do is have it like, if I needed this, uh, when I click on a block to do something with the score on the screen, tell a different thing to do that. Okay. And so let me close that one out. And let me open up another thing. Okay. So for example, here I have what's called the game mode. Okay. And I have a function that I've defined that resets the game. So when there's a stalemate or somebody wins, it resets the game back to the beginning. And um, right, code, right, and so you don't have to really worry about what all of these different little pieces mean, right? Because I'm not trying to teach you all of Unreal Engine in 10 minutes, but um, this is visual coding, and it's in a AAA game engine. And I bet you, if we were to go to the developers of Elden Ring, that we would, and say, here, can you pop open the project in Unreal Engine and poke around, there'd be some of this blueprint code someplace. Okay. Now, a lot of it would also be in C++. Okay. But not all of it would be. And in particular, so let me open up a different project here, because the tic-tac-toe is kind of a silly one. Oh, that's not what I meant to do. Yeah, it is. Okay. All right, let me open up this project, which is a bit more extensive. All right, so let me just demo what the game is supposed to do. Okay, Okay, so you guys couldn't hear that, but it just, when I picked up that coin, it made like a ding sound. Okay. All right, so I've got all this stuff. Well, so like, let's take this coin, for example, right? There's a couple things happening. One, it's rotating. And two, when I overlap with it, it does something, okay? And where would be a good idea to put that code? Well, how about here with the actual coin itself, okay? And so all of the coin here is, right, tied to, there's a little sphere that's hidden that's around it. And when the player overlaps with that thing, I want to have it pick up the coin. Well, what is involved with picking up a coin? Say. Hmm? Yeah, add one to your score. Okay, what else? Make a noise. Uh, yeah, if it's like an item where there's like an icon that you have it, then add that, like something in the UI. Okay, and then also once you picked up the coin, you should delete it. Right? So in MakeCode, right, this is destroying. It's sort of the same thing here. And so what happens if you overlap it? Well, I'm going to update my coin count by 1. Okay, that makes sense. What else do I need to do? Update the number, like the coin display in my HUD, right? So there's like a number there on the HUD that says you've got 5 coins or whatever. Okay, then what? Play a sound and destroy that thing, right? So that makes complete sense, right? And all this other stuff about, like, well, where do you want to play the sound? Where would be a logical place for the sound to come from, so to speak? The coin itself, right? Okay, well, where is the coin? I need to ask basically, hey, coin, where are you? Play the sound at that location, okay? And then, or like here, for updating the HUD, like the display on the screen, well, what HUD do I want to update? Well, I want to update this one, right? Because you could actually have multiple HUD objects on the screen, and that would make sense because maybe you have like your game thing, and if you hit a button, then like your inventory screen comes up or something, or like a main menu or the map or whatever, right? Those can all be different objects. And it makes sense that you'd want to be able to turn some of them on and off independent of others. For example, like I said, an inventory screen or a map screen or something along those lines. Okay, but um, do you think so? Who do you think in, like, let's just say Elden Ring? Let's imagine that there's coins scattered around the world. Okay, there's not in that sense, but whatever, right? Who do you think would have programmed this for the coins in a game development kind of environment where there's like lots of different people on a team? Yeah, but would it be like the dude whose job title is programmer? Probably not. Okay. The dude whose job title is programmer is the guy who's making all the engine stuff work in the background, and graphics and networking and all of that, right? So the person who would have been doing this kind of code would probably be the person designing a particular world, okay, who is not necessarily a programmer by trade. They're probably more of an artist, if you will, okay? And they would have maybe a background in, well, they could have a background in whatever, but if they had done formal schooling for this, it would have been like in game design, art, architecture, some skill like that, okay? Um, and Blueprint, the reason that Blueprint has evolved is because Epic and um, lots of other game developers, right, realized that, you know what, having a simple, very intuitive scripting system that you can give to the designers of your worlds that allows them to do simple programming tasks frees up your actual programmers to do the stuff that needs actual programmers. Okay, so you could hand this to an artist, and with a little bit of training, they could do stuff like this, okay? Or like, let me go back to the game for a second. Um, so when I opened this up, I was standing in front of a door, okay? And let me just kind of find my way back over there. Um, okay, so where was it? It was up here someplace. Okay, so there's this door here, and you see how when I get close to it, it says the key is needed, and if I hit E, it doesn't open because I don't have the key. And then this thing was a jump boost power up that this is something I did with a previous class. Um, he says, see how my jumping is normally kind of low, but then if I get the boost, then I can jump higher. So an artist or an architect would be the one to program this thing. Oops, I missed it because I wanted to get up there to the like mega coin or whatever. But anyway, like if I were the world builder, then I could put the blue key somewhere in this world. Okay, I forget where it is, but it's out there someplace. And then when I get it, have this door programmed in such a way that it'll open only if I have the blue key. Make sense? Yeah. And by freeing up the designer of this world to do all of that, or sorry, giving them the tools to do it rather than the programmers, that increases the speed at which this stuff gets developed. Okay. So, um, yeah, so AAA titles are using this stuff. And like I said, with Elden Ring, I would lay money that there is blueprint code somewhere in that game. Um, yeah, it'd be kind of interesting to see like an example of it, but without them giving away the farm, right? Because they're not going to show us the entire source code, but what we could get is sort of an example of where they've used Blueprint. Okay. Um, okay. So, uh, right. So there's basically, a little bit of Unreal Engine, and each object can have its own kind of code with it, and you can have multiple instances of a given object. So, for example, the coin. Do I have to make like 50 different versions of the coin? No, I just need one of them. And then every time I want to put a coin in the world, I just put another instance of it. And they all work with the same piece of code. Similar, we did some um, when we did this, we made a jump boost, and then we said, okay, well, let's also do like a double jump ability, and then there was the blue key, um, and visually they look very similar, so we kind of recycled some of the art from one of them to make a new piece, um, and then there's the thing for the door that's locked. There's a thing for the like at the end of the game there's like a you can't quite see it but like a portal you want to jump through and that sort of triggers the win screen. um, a real game obviously is going to have way more stuff than this, but there's also at one point like checkpoints that you step on, so like like in Super Mario or um, say Sonic, right? If you get halfway through the level, there's like a little thing that you trigger, and then if you die after that point, what happens? Do you have to go all the way back to the beginning of the level? No, you start now at the checkpoint. So there's several of these in the game where if you fall off the edge of the world, okay, in this case, and fall to your doom, then you'll respawn at the last checkpoint that you've reached. Uh, and when the game starts, it's we broke this for development reasons, but strictly speaking, we should have always started in the same location. And we turned that part off so that we wouldn't have to play through the whole level every time when we made a change. But yeah, okay. So does that kind of make sense? Yeah, that like so the visual scripting. There's nothing wrong with it. Um, it uh, it can be used in real development. but it has to be built around using it in real development. Okay. Okay. So I think that's kind of what I wanted to hit with you guys. Was just sort of a taste, if you will, of what's to come next. Yeah. Question
Do you know anything about the Frostbite engine?
about which engine?
The Frostbite engine for EA?
I do not.
I was interested, honestly,
Yeah.
because
Um,
I always hear that, well, at least just the way they even do all of their games and stuff, at least for their sports games,
mhm.
that it's like even they have maybe they have a big group of people coming up with ideas, but they're just feeding off ideas to low level programmers who have no idea, I guess, of what they're doing. So they're or like they're not, I guess, invested in the game,
Yeah.
and so that's why it's always causing problems.
Well, and the thing about engine development, okay, so with Frostbite, or and it's not the only example of this. Okay, that engine is one that EA develops, right? So EA, some division of it, there's a team whose job is to do nothing but develop that engine. Okay, but if I, as a customer, want to, let's say I own a game studio and I want to develop a game, can I get Frostbite? No. Okay. They develop it only for use within the EA company. So how exactly it works under the hood or the interface and stuff is sort of proprietary knowledge that we can't really know. Now, Unreal Engine is and Unity and others are a little different. Okay. So those, the source code and all the documentation and stuff is freely available online. I could download it right now. Okay, so then you ask, how does Epic make money? Because I mean, they kind of like to make money, right? The money's kind of nice, right? So how do you make money if you basically give away your source code for free?
Are you saying that EA?
Epic,
Yeah.
yeah, for Unreal Engine, say.
And that they give them things to buy.
Okay, so there's two ways that they make money. The first, and this is, I suppose, enough, right? Is you make a game that's free called Fortnite, and then you make all these stupid looking skins for the characters that make your player look cool, supposedly. But how do you get them?
You pay them $20 for real
Oh,
skins.
you got to get V-Bucks. Okay. And so if you've got a 12-year-old that's playing Fortnite, now how many of you guys, when you were little or younger, like begged your parents to buy you V-Bucks so that you could get some stupid skin in Fortnite? Maybe some of your siblings? Does anybody have siblings?
My cousin actually stole his dad's credit card and his house, so he spent almost $1,000 on it.
Wow.
I've done that before, but on subway surfers, I didn't know I had a card attached to my phone, so I accidentally clicked one and it went through. I was like, oh shit! So I kept clicking $100. It was messed up.
And you're still alive to tell us this story,
Yeah, just
right?
don't ask me.
Yeah.
But um, he also switched a used, I think, Amazon card for a unused Amazon card uh, from his brother, and he found out his brother found out a few days later. Then basically his punishment, he had to apologize and was supposedly grounded for a week, and then
That's it?
like a day after he was playing. So he got to keep the card.
Yeah, that sounds like not so great
Well, because
parenting.
he instantly used it. So
Yeah.
he got the better half of that deal.
Yeah, grounded for a week. No, that's like grounded for life. Um,
I think for the $1,000 whatever, he was supposed to be grounded for a month.
that's going to be a lot of mowing the lawn to pay off that debt.
1 week, that's just enough time for his Amazon shipment to come. And then
Yeah.
instantly a week, and then a week later, he was
Yeah.
for
Kids see, huh?
his birthday, he got all of his friends just got him V-Bucks. Because he had $200 worth of V-Bucks.
Oh, that's hilarious. Yeah. But yeah, that's one way that they make money, right? Is selling in-app purchases for V-Bucks. Okay, and they've just like it's almost as if they just installed a money printer at the factory, right? Like it just spits out money. Okay, but so there's that. But the other way that they make money is so let's say that I'm a developer, all right, and I own a game development studio, and I make Elden Ring, okay, and I sell Elden Ring for $59.99, which is sort of the standard price for games nowadays, right? Well, what's going to happen to that $59.99? Yeah, exactly. Epic gets a cut of it, right? And the percentage of cut that they get depends on how much money you have. Okay, now there's also the cut for like if you publish it on Epic's Game Store, but that's separate, right? Because you could also publish it on Steam or any other place. Okay, so they make their money for the engine development by having developers that make games with it and ship games with it. Epic gets a cut of that. Okay, now for me as like an indie developer or an educational developer, right? They don't charge me any money, right? So if I make a game and launch it, if it's free, I pay Epic nothing. The second I start making money, though, is when I then owe Epic money. And I'm not making games for to make money. I'm making things to teach. So yeah, and so why is it in Epic's best interest then to sort of give their stuff away for free? Well, because then people like me teach it and you learn it, and let's say that 5 years from now you're working at a video game developer, and or maybe you say you found your own studio, and then you're like, well, which engine should we use? Well, if you have previous experience with Unreal, maybe you'd pick that, and then maybe you'd make the next Elden Ring and make billions of dollars, and Epic gets their cut of that $1 billion, right? So that's kind of how the economics of it work. So the things were a little different in the 90s and 2000s, where you would go to Epic and you would license the engine, but the license did not come with this sort of royalty kind of model. The industry has moved a little bit. And then so essentially every game engine back in the day was closed source. You had to license it before you could see all of the code underneath or get any of the tools. Um, and then, so other companies did this. So, for example, how many of you guys have played Doom or Doom Eternal? Yeah. So, id Software, which is now a sub studio under the Bethesda umbrella, which means now it's under Microsoft because Microsoft bought them. So Bethesda did the Fallout series and the Elder Scrolls series. Um, so id worked like this back in the day. They made their own games, but they were really, for lack of a better way of putting it, tech demos for the kinds of things that their engine could do. But where they really made their money was from licensing the engine to other companies that would then make their own games with it. And similar in some sense to the way Epic kind of got started with licensing the Unreal Engine. Now, when Bethesda bought id, they basically decided that they were going to get out of the engine licensing business, and now the engine that id develops, is only used for Bethesda games. It's only used within the family. And I suspect that, what was it, Frostbite, is a similar sort of thing, but within the EA family of companies that, just any old company can't use it. But if you're an EA owned studio, then you can. Um, yeah.
Yeah, I just heard so many bad things about the engine and stuff
Yeah, nothing beyond that. It probably works that way, and that's not the only example of it. I mean, so a good, actually, example of this would be how many of you guys played or heard about Cyberpunk? Right. So, what was the story with Cyberpunk? Huh? Yeah, it was released in a very buggy, unfinished state. Okay, and one of the reasons, there were many reasons why that happened, but one of them was the engine that they were developing it on was something that they had designed in-house and had been, uh, well, things had been tacked on and tacked on and tacked on over the years because they used a previous iteration of it for one of the Witcher games, right? And they were basically pushing the engine beyond what it was, like it was just getting ridiculous. So CD Projekt Red, which is the developer of that, has basically decided, you know what, we're done making our own engines. And so they signed a deal with Epic, and they're going to use Unreal Engine for future projects. And basically let Epic deal with the engine stuff and them do what, honestly, I think they really wanted to do, which is be able to make games and not have to worry about the engine itself. So, yeah, anyway. Um, So yeah, that's sort of video game economics, if you will, or at least on the development end. And there's a lot of these other engines, right? So did any of you play the Deus Ex, Mankind Divided, or Human Revolution? Right, that had its own engine and stuff. What the developer tools look like for that, no idea, um, because it's closed source. Um, Whereas Unreal, Unity, those are the two biggest players that AAA games are using. Is usually one of those two. So Unity does have a visual scripting system. I don't think it's quite as robustly developed at this point, but it is there. Um, and but I've known the Epic or the Unreal Engine well since Unreal One back in 1997. So when none of you were alive. So anyway. Okay, well, I think that's probably good for today. So please make sure that you get your uh, your second submission. You'll have to reshare your new project, or wherever you are, so that we can do the second iteration of peer review. And hopefully, Canvas won't screw it up this time, and everybody will put valid links in. Okay. So, any questions, Preguntas and/or Fraggens? Okay. So Thursday, I've kind of done everything I want to do. So Thursday we can just work, right? That's cool. Nothing specific content wise. All right, and then of course, well, actually, let's make sure we're all on the same page. When is the project due? Thursday next week. When? Whatever time it says on Canvas, right? So that is when our final exam would have been if we had a final, but I'm not going to give you guys a final because that seems pointless for this class. Yeah, 4:30 or 16:30, right? Um, so yeah, okay. And all you got to do is turn in the link and then also give me some instructions and description and stuff like that. But about what the controls are, what the objective is, and so on. Okay, Gucci? Yeah. Sure. Let me turn off the stream and then we can log.